Okay, so we are continuing with the same paper, IGCSE 062042 of 2021 October November. Okay, and this is question number 4. Here we say this is a reversible reaction and carbon chlorine reacting with carbon monoxide to produce phosgene gas. The forward reaction is in forward exothermic. Keep that in mind. It will help us to explain the effect of changing temperature or pressure on equilibrium, okay, or the yield. The question is, explain why the rate is exothermic in terms of energy changes of bond breaking and bond making. So we can write it very easily. How? Just say energy required to break bonds is less as or than energy released to make the bonds. So here you confirm that first the energy difference is greater in releasing, and you also confirm that during bond breaking energy is absorbed and during bond making energy is released. Understood? So I'm going to the next part, the energy profile diagram. Okay, he says that complete on your own diagram show the product of the reaction. So we are going to show the product of reaction. The arrow representing the energy change labeled as delta H, an arrow representing the activation energy. So we have to represent three things. First of all, remember the reaction. The main reaction was exothermic. It means the reactant level is higher as compared to the product level. So like this, here we have to show the product. Product was a phosgene gas, COCl2. And then we have to label from this level till this. This is activation energy. And he said label it as label A. Okay, so we are going to label accordingly. It is A. And then enthalpy change is from reactant till product. This is delta H. So we shown properly the products, we shown the activation energy and delta H. So it's complete here. And next it says state why catalyst is used. Very simple. We can say to increase the speed of reaction. To increase rate or speed of reaction. Okay. So this is the possible answer. Next, C, it says that describe and explain the effect, if any, on the position of equilibrium when the temperature is increased. We have the knowledge in the main reaction. Like you can see, this was the main reaction. One molecule of chlorine, one molecule of carbon monoxide reacting to produce one phosgene gas. But remember, on the left side we have 2 moles, whereas on the right side we have only 1 mole. So increasing the pressure always shift the equilibrium from more moles to less mole. So what we can say, what will be happen to equilibrium? Equilibrium shift. First of all, we can say yield increases. Yield increases as equilibrium shifted from more moles to less moles. Next, he says the temperature is increased. The temperature, we learned that whenever we increase the temperature, always endothermic reaction favored, which was the backward reaction. So what we can say, yield decreases. Yield decreases. Why? Endothermic reaction favored is favored, which is backward, which is backward. Next, again the reaction is given, and you have to keep that in mind. What type of the reaction bonds we have, and then he says use the information to calculate the energy of the bond between carbon and oxygen in carbon monoxide. Furthermore, you have to learn that what information is already given. He says that the reacts and this energy is released. Okay, so we can say the energy, and we know the formula. I'm going to write over here. Delta H, enthalpy change, is equal to sum of bond energies of reactants minus sum of bond energies of products. But remember, in your exam, you may not have to write the formula. Just keep the formula in your mind. Okay. Now, by using these values, I'm just calculating what is the amount of energy in chlorine. So this is 240 plus. But we don't know what is the amount of energy involved in carbon monoxide. And here we have two types of the bond. One is carbon to oxygen double bond, whose value is 745 plus. We have two bonds of carbon and chlorine, so we can say 2 times carbon chlorine bond is 400. So what is the answer? 745 plus 2 times 400, which is 800. 745 plus 800, what is the answer? 1545. Whereas here we have only one. So use this formula. He says that delta H, which is 230. So we can simply say 230 is equal to reactants, which is 240 plus X, and then minus what value we have? 1545, which is the energy of the products. Now solve this equation. So you will get that 230. This value comes here and it will become negative 240. This is negative. When you come to this side, it will become positive. It is 1545. That is equals to X. So finally, the value of X is 1535. So this could be the answer, but you have to follow and you have to calculate accordingly. Okay, this is the main formula. Just put the values of reactant and product, and you can get the correct values. Understood? So next part of the same question, it says complete the dot and cross diagram to show the arrangement of electron arrangement in a molecule of COCl2. So you can see here the information for you that carbon is total proton number are 6 and the structure will be 2 and 4. Indicates it is going to share only 4 electrons. Oxygen proton number 8. Electronic structure 2 and 6, indicating it is going to share only 2 electrons. For chlorine, proton number is 17, structure is 287, indicate that it is going to share only 1 electron. As I directed and advised, please start from the atom whose requirement is less. So in this case, it is what? And here you also, as 3 different atoms are used, so you may use the key as well. Okay, I can make the key. So you can say for chlorine, I'm going to use cross. For oxygen, I'm going to use dot. And for carbon, I'm going to use this box. Okay. So this you may draw the key by your own. Now, as I said, start from chlorine. So chlorine is going to share one electron here and one electron here. Out of seven, one electron is shared. So how many are still there which are not bonded? Six. So we have to show all those six electrons. Same is the case with this chlorine atom. Understood? Now, carbon will share accordingly as two electrons are shared. So mutually it will share two of the electrons, and we have to show the box here. So two electrons are shared over here. But oxygen requires to complete their outer shell by two electrons, so it will share two of its electrons, 1 and 2. Carbon will also have to share two electrons here and here. And now out of 6, 2 are shared, so 2 are still unbonded. So we have to show like this. So if you're not making the key, not necessary. If you make, that's good. Okay. Even you may use all the crosses or all the dots.